those two equations, just as we solve regular linear equations, and we get two answers. X equals 7, x equals -3. What should we do with those two answers? We should check them by replacing the x with first 7. 7 minus 2 is 5. The absolute value of 5 is 5. It checks. Replace the x with -3 in the original equation. -3 minus 2 is -5. The absolute value of -5 is 5. So our two answers check. Something I should emphasize, I've talked about checking all the way through these tapes. Remember, you always want to check in the original equation, the equation that was given to you, because if you check later on, what if you made a careless arithmetic error going from the original equation to where you're checking? Your answer would check, but it would not be the right answer because you didn't check it in the original equation. I must emphasize that. Okay. The next visual has a problem that's a little bit more challenging, but I think we can do it. And it's all laid out for you. And again, on this tape, rather than taking all the time to solve all the problems, the solutions are given. What I would hope you would do is write down the original problem, and at a later time, later today or tomorrow or later on this week, work the problem, check the answer. If you get it wrong, go back and look at the steps. Because anytime we have an absolute value equation, the very first thing we want to do is isolate the absolute value. So what do we do here? The first thing we do is we add -8. We add 8 to both sides. Notice in this case, again, I'm treating you guys a little more advanced now. I'm not showing you all the steps. We did that earlier in this lesson, but now we're big time here. So we are adding 8 to both sides. We get 3 times the absolute value of 2x minus 6 equals 18. Okay? We still have that 3. We have to isolate the absolute value. Get it by itself. We need to get rid of the 3. So multiplying the absolute value by 3, we divide both sides by 3. We get the absolute value of 2x minus 6 equals 6, which means what's inside that absolute value can either be 6 or it can be -6. So we have our two equations. 2x minus 6 equals 6. 2x minus 6 equals -6. We solve and get 6 and 0. Plugging 6 or 0 back into the original equation, they both check. Now that we can do that problem, let's see if we can do something more challenging. Something that takes advantage of everything we've learned in this lesson. Let's go over here and take a look at this problem. A little more complex than before. But notice, one absolute value, a bunch of numbers, letters, etc. What's the first thing we want to do? The first thing we want to do is to isolate the absolute value term. Let's get rid of all the nonsense that doesn't have anything to do with absolute value. Get it on the other side of the equation. So, let's see. We'll leave this alone for a while. And now, we want to get rid of the -9 and want to get rid of the 8x. Let's get rid of the 8x first. Subtracting 8x, well, 8x minus 8x is 0. Sometimes when you have a problem that looks difficult, in actuality, if you do it step by step correctly, some of the difficulty may vanish very quickly, as in this case the x's vanish. We add 9 to both sides and we get 15. Okay? Notice, in one step, we took a problem that looked quite complex into something that doesn't look very complex at all. All right, we still want to isolate the absolute value. We got this 3 over here. We divide both sides by 3. And now we say to ourselves, okay, what we want is a number whose absolute value is 5. Well, there are two numbers whose absolute value is 5, 5 and -5. All right, so we have 2x plus 3 equals 5, and the other solution would be 2x plus 3 equals -5. And now we're back to the kind of equations we did at the beginning of this lesson, something hopefully you were able to do in Algebra 1, so we solve them. Subtract 3 from both sides, 2x equals 2, divide both sides by 2, x equals 1. Again, subtract 3 from both sides. Again, -5 minus 3, -8. Divide both sides by 2. We have two solutions. Always check in the original problem. Let's try x equals 1. 2 times 1 is 2, plus 3 is 5. So we have 3 times the absolute value of 5, minus 9. 8 times 1 is 8, equals 8 times 1 is 8, plus 6. The absolute value of 5 is 5. 3 times 5 is 15. 15 minus 9 is 6. 6 plus 8 is 14. 8 plus 6 is also 14. That checks. Let's check negative 4. Negative 4. 2 times negative 4 is negative 8. Right? Negative 8 plus 3 is negative 5. So we have 3 times the absolute value of negative 5 minus 9 plus 8 times negative 4. 8 times negative 4 is minus 32. Okay? Equals 8 times negative 4, which is minus 32, plus 6. The absolute value of negative 5, of course, is 5. 3 times 5 is 15. 15 minus 9 is 6. 6 minus 32 is negative 26. Negative 32 plus 6 is negative 26. Both answers check. And until you've checked, you never know you're right. And once you've checked, you know, as in this case, that you are right. Let's go back and talk about what we've seen in this lesson. We started with some very, very simple equations. And we saw the thing you want to always do is to isolate the variable. If you have a variable on both sides, if it's a positive, like a 2x, subtract 2x. Tell you what, rather than talking about it, let's go ahead and go back over here just for a quick little review of, if you, for example, we're not going to solve these, but let's say we had 4x minus 9 equals 2x plus 7. We want to get the 2x away from there, subtract 2x from both sides. Had this been a negative 2x, we would add 2x to both sides to get the x on one side. Same thing with the numbers. If for whatever reason we brought the x over here, we wanted to isolate the x term and get rid of the negative 9, we'd add 9 to both sides. If we had, for some reason, we wanted to bring the positive 7 over out of there, we would subtract. Since it was plus 7, we would subtract. Always doing the opposite. And again, we don't want the letter and the number terms on the same side. We want the letter term on one side, usually the left. We read left to right, and the number term on the right side. Remember, if you have parentheses, let's say like 4x minus 2, multiply each term in the parentheses by the number outside. Remember, if you have terms that are of the same type, let's make it even more interesting, minus 1. We would combine the x terms, positive 4x, negative 5x is a negative x. A positive 2 minus 1 is plus 1. Combine it, get it down to only one letter term and one number term, because once you're here, you're back to an equation such as that. Okay? And then with absolute value, remember, isolate the absolute value. Once you've got absolute value equal to a number, for example, I don't care what this is, some algebraic expression, 5x plus 7. If it's equal to, let's say, 9, then you would set what's inside the absolute value equal to 9. What's inside the absolute value equal to negative 9. You would get two equations, solve them, and go back to the original equation to solve and check. Now, if you can do all those things, you should have no problem solving linear equations or linear equations that involve absolute value. Hopefully you can do this, because the next lesson that we're going to tackle in lesson 5 is going to be solving linear inequalities. And inequalities are very similar to equations, except instead of having equals, they have less than or greater than. But the means we use to solve those inequalities, and later on even solving absolute value inequalities, we based on the lessons we learned here today. So if you can solve a linear equation, if you can solve an absolute value equation, then you'll have no problem with inequalities. We'll see you then.